Hello everyone. Today we're going to be looking at our standard form for quadratic functions, which is written right here. So we're going to go through some different characteristics. We're going to look at how to calculate intercepts, x-intercept and y-intercept. We're also going to look at comparing it to the vertex form. And then we're also going to find some characteristics where we're given a function in standard form. Okay, so let's scroll back to the top. So for standard form, A is going to be just this number right here in front, and that's always going to tell us the direction of opening. So if A is positive, if A is greater than 0, it's going to open upwards. And if A is less than 0, it's going to open downwards. The C value in our standard form is what's going to give us the y-intercept, so it's going to occur at 0 and C. So if C was a 5, this would be 0 and 5 as our y-intercept. Next thing we got is our intercepts. So you guys should have heard of this before from Math 10C. So x-intercept is the x-coordinate of the point where a line or curve crosses the x-axis. It is the value of x when y equals 0. And it's going to occur at x and 0. Okay, so the reason it happens when y is equal to 0, if we look at this graph here, y equal to 0, this is y at 1, at 2, at 3, and so on. But if I go all the way down at a height of 0, you can see that's where my points are going to cross the x-axis, so that's where we have our x-intercepts. For the y-intercept, it says that the y-intercept is the y-coordinate of the point where a line or curve crosses the y-axis. It is the value of y when x equals 0. And then it's going to occur at that point 0 and y. So I'll explain this one. So it happens when x equals 0 because if we had 1, 2, 3 for x, if I move this way, that's going to get me to where x is 0. And I can see that along that line, that is where I'm going to have my y-intercept. Okay, so y-intercept occurs where x equals 0, and then x-intercepts occur where y equals 0. Okay, so we'll have to use that in order to find an x-intercept or a y-intercept. Now the next thing we're going to look at is determining the vertex. So we're going to start with our vertex form, and then we're going to change it into standard form, and then we're going to compare the two and see how one relates to the other. So all we're really trying to do is FOIL this out and then simplify. So first thing I'm going to do, I'm going to apply that exponent of 2. So this is going to be a times x minus p times x minus p plus q. And then I'm going to FOIL everything out in here. So I'm going to have x times x, x times negative p, that's negative px. Then I got this one, negative p times x, that's negative px. And then the last one, negative p times negative p, that's just positive p squared. Okay, and then all of that was being multiplied by a. So got to put brackets around all of that. Then we got plus q. Okay, then I'm going to simplify inside of here. Those two can go together. So I have minus 2px and then plus p squared. Still have brackets, and then plus q. Okay, and then now I'm going to distribute the a into all of the terms there. So I'm going to have ax squared minus 2apx plus ap squared plus q. And then to get this into standard form, we should have our x squareds first, our x's second, and then our constant term last. So I am going to just write the terms kind of in front in a different color, just so they stand out a little bit more clear. Okay, and then I'm going to write my standard form below this and compare with what we just got with the standard form. Okay, so I can see A is still A, that hasn't changed. Those two go together. To get B, it is minus 2AP, and the C is all this last stuff, it's AP squared plus Q. Okay, so now I know which one goes with which. Now the reason this is important is because the P and the Q, up top here, the P and the Q, those were the points of the vertex, the X point and the Y point. So if I could somehow relate that to standard form, then I can figure out what the vertex is from this standard form here. So I want to relate the P and the Q to this A, B, and C. So let's write out what we had down below here. I knew that B was equal to negative 2AP. Okay, and then I'm going to divide both sides by a negative 2A. Those will cancel. And so I get P, I just switch sides here. P is equal to B over negative 2A. So the X point of the vertex is just B over minus 2A. Okay, and then taking these two, and I'll say that C is equal to AP squared plus Q. So let's write that out. And then I'm going to subtract on both sides by AP squared to get rid of that. So Q is equal to, I'm just switching sides again, C minus AP squared. Okay, so Q just came to this side, and then this stuff went to that side. So my vertex, if I wanted to find my vertex, it's going to happen at P and Q. We knew that from before, but that's just going to be equal to B over negative 2A, because that's what the P was we just found. And then the Q is C minus AP squared. Okay, so that's our vertex. Next here we have some examples. So it says for each function, sketch the graph of the function and identify the following, and then we got these characteristics. Now graphing you always want to do last. So you want to find your characteristics first and then use those to help you graph last. Okay, so first characteristic we're going to find is the direction of opening. I'm going to do those down here. They're just going to be labeled for each. So in the direction of opening, I knew that if this A value was positive, it was going to point upwards. So I'm going to say A is positive, it's greater than 0, therefore it's going to open upwards. The vertex, to be able to find the vertex, we're going to use what we just found on the last page. So I know the X point is equal to minus B over 2A. And then I'm going to fill that in from these letters over here. It goes A, B, C. So it's going to be minus, and then B was 12. And then we got 2 times A, and A is a 2. So this is going to be negative 12 over 4. And that just equals negative 3. To find the y point of the vertex, it's easiest to just take the function and then plug in x equals negative 3, and that'll give us out the y value. So take this function here. So it's 2 times x squared, I'm just going to put the blank, plus 12 times x plus 10. Okay, and x was negative 3, so I'm just filling in that x was negative 3. Okay, and then when you simplify that, you are going to get negative 8. So our vertex is at negative 3 and negative 8. Goes x and then y. Next we have the max or min value. Now we had said up top here, we said that it's going to point upwards because A was positive. So if it points upwards, that means it's only going to go as low as this point, and then everything else is going to be above that. So it's going to have a minimum point, and where that occurs at is this y value. So it happens at y equals negative 8. The axis of symmetry is always just x equals and then the p, and then this is the p. So our axis of symmetry is x equals negative 3. Now for our x-intercepts and our y-intercepts, these are going to be a little bit harder. They require a little bit more work. So x-intercepts, these occur at when y is equal to 0. So I'm going to change y to be 0 and then solve. So we started with this. Y equaled, let me look back up, 2x squared plus 12x plus 10. And then we're going to change the y to be 0. So I got 2x squared plus 12x plus 10. And then to solve this, we're going to try to factor this and then set each factor to 0. So first thing I can do though, I can divide everything by a 2. So every single term, this, all of these will get divided by 2. And that'll leave me with x squared plus 6x plus 5. Okay, and then I'll do my product and my sum. So the product is hidden 1 times 5. So the product is 5. And the sum is the middle term. So it's a 6. The two numbers that multiply to 5 and sum to 6 are 1 and 5. Okay, so I'm going to just pull my work back up over here. So to factor this, we use those two terms that we just got. So it's going to be x plus 1 in brackets and x plus 5 in brackets. Okay, and then I'll just take each of those and set them equal to 0. So x plus 1 will equal 0, and x plus 5 will equal to 0. So on the left one, I can subtract both sides by a 1. And then that's going to give me x equals negative 1. On the right one, I can subtract both sides by 5. And I get x equals negative 5. So those are my two x-intercepts. So it's going to be at negative 1 and 0, and negative 5 and 0. Remember, it goes x and then y, and we knew y had to be 0 because that's what we had at the start. Y was 0. Next we have the y-intercept, and this is going to be usually quite a bit easier. So this is when x equals 0. So let's write out our initial function and then change the x to be a 0. Okay, so we get y is equal to 10. We could have done that another way where we just know that whatever this last term is, that is going to be the y-intercept. And that's what we had written on the very first page. So our y-intercept is at 0 and 10. Domain for quadratics is just x is an element of the real numbers. The range, it's going to be y given that. And then y in this case, it had to be higher than this point of negative 8 because that was the minimum point. So y has to be greater than or equal to negative 8, and y has to be an element of the real numbers. For vertex form, so vertex form was this. I'm just going to write it in blank. Okay, and then we just got to fill in the a, the p, and the q. Now the a doesn't change, so it's still going to be a 2. The p was the x point of the vertex, and we found that above here. That was negative 3. So let's write that in. And then this is also going to be the q point. So negative 3 and then negative 8. So I wrote in the negative 3, wrote in the negative 8 for the p and the q. And then these two negatives, those are going to give me a positive. So just to save some space, I'm just going to change it right here. It's going to be x plus 3 now. Okay, so now that I have all those characteristics, I'm going to use those to plot my graph. So going up here, I know the vertex was at this point right here, so let's plot that. So at negative 3, we're down at negative 8, so that is way down here. So there is our vertex. We had a x-intercept of negative 1 and 0 and 5 and 0. So let's plot those. Negative 1 and 0, negative 5 and 0. And I also had one other point, we knew the y-intercept was at 0 and 10. So let's plot that. That is going to be actually up off my graph. This is at 8, so 9 would be a little bit above that, and then 10 is even higher than that. Okay, and now we can sketch our graph going through those points. And then at the end of our lines, just make sure you put your arrows on there. This next example, if you want to pause the video and then try to do it on your own, you could do that first. And then just click play when you're ready to come back. So for the direction of opening, I can see that A, that's this number right here, it's just a -1. So A is less than 0, it's negative. So it's therefore going to open downwards. The vertex, we're going to have to find these points. So I know the x was at -b over 2a, and this is my a, b, and c. So my b, I got minus, and then b is a 2. And I got 2 times a, and a is -1. So in the bottom, I got 2 times -1, that's just -2. And then divide those, I get a +1. To find the y, I am just going to enter in that value of x equals 1. So it's going to be 1 squared plus 2 times 1 plus 8. Again, I'm just plugging it into the original function here. And then when we simplify that, we are going to get 9. Okay, so my vertex is at 1 and 9. X and Y, or you could say P and Q. Max or min value, we had said it's going to point down, so it's going to have a max point, and then everything's going to be below that. So we have a max, and that occurs at y equals 9. Get that from right there. Axis of symmetry is x equals, and then the x point of the vertex, so that's x equals 1. X-intercepts, that's when y is equal to 0. So let's plug that in. So we'll write out the initial one. It was y equals -x squared plus 2x plus 8. And then change the y to be a 0. Okay, and then with this one we got a leading negative. What I'm going to do is I'm going to divide every term by -1. So again, it's got to be every single term. So I get 0 equals x squared minus 2x minus 8. So essentially all the signs just switched. Okay, and then I'm going to do my product and my sum. Product is going to be -8. Sum is that middle number, -2. So we got to multiply to -8, sum up to -2. So that would be -4 and 2. So breaking it apart into our factors, we got x minus 4 and x plus 2. Take each of those, set them equal to 0. So I'm going to have x minus 4 equals 0. Add 4 onto both sides. 4's cancel. So x equals 4. And similar idea with this one, x plus 2 equals 0. Subtract 2 from both sides. And then x equals -2. Okay, so I got two x-intercepts. One is at 4 and 0, and then the other is at -2 and 0. Y-intercept, usually this one's a little bit easier. It's when x equals 0, or it's just the c value, whatever is at the very, very end here. So that +8, I know my y-intercept is going to be at 0 and 8. Domain, again, that one's simple. It's always x is an element of the real numbers. And then curly brackets around that. Our range is y given that, and y had to be, let's look back, y had to be below this point. We had to be below whatever the max was, and that happened at 9. So we have y has to be less than or equal to 9, and y is an element of the reals. vertex form. I'm going to write the blank, and then we'll fill it in. So the a doesn't change, it's still the same. A was -1. And then the p and the q, we had actually labeled those up here. So they are right here. So p is 1, and then q is 9. So p is 1, and q is 9. Okay, and then the last thing to do, we just have to take all this information and then graph this. So our vertex is at 1 over and then 9 up, so that's actually just off the graph. That would be at a height of 9 there. Our x-intercepts were these right here, so 4 and 0 and -2 and 0. So 4 and 0, that's right there, and then -2 and 0 is right here. Our y-intercept we had found was at 0 and 8. So 0 and 8 is right there. Okay, and then I can graph my parabola going through those points. And then just make sure you got arrows on the end of your parabola. So that was our last example. I'm just going to write down our homework here. So it's on page 174, and we have numbers 1 to 3, 6 to 10.